Hi all, this is Priyadharshini working as an assistant professor in the Department of Artificial Intelligence and Data Science. Today we are going to discuss the topic algorithm in design and analysis of algorithms. Let's continue with the topic. So what is an algorithm? In computer science, an algorithm, it is a sequence or a finite set of instructions for solving some problem step by step. A finite set of instructions solving step by step. Typically, the algorithms can be solved by computers and humans as well. For instance, if you want to count the number of people in a room, well, you are like me, you probably point at each person one at a time and count up from 0, 1, 2, 3 and henceforth. So this is how we'll do. So an algorithm, in fact, let's try how to express it a bit more formally in pseudocode. Pseudocode is English-like syntax that resembles a programming language. First thing, let n is equal to 0. For each person in a room, set n is equal to n plus 1. How to interpret this pseudocode? Well, line 1 declares a variable called n and initializes its value to 0. This means at the beginning of our algorithm, the thing which we are counting has a value of 0. After all, before we start counting, we haven't counted anything yet. Calling this variable n is just a conversion. I could have called it almost anything. Now in the next thing, I will repeat a sequence of steps that will repeat some number of times for each person in room. For example, for each person in room, set n is equal to n plus 1. So which describe exactly how we will be counting. The indentation implies that's in line 3, that is n equal to n plus 1, that will be repeated. So what the pseudocode is saying, it is after starting at 0, for each person in the room, we will increase n by 1. Now is this algorithm correct? Let's see. Well, let's bang it on it a bit. Does it work if there are 2 people in a room? Let's check. So in line 1, we initialize n to 0. For each of these 2 people, we then increment n by 1. So in the first step, through the loop, we update n from 0 to 1. On the second step, through the same loop, we update n from 1 to 2. And so, by this algorithm's ends, n is 2, which indeed matches the number of people in that room. So far, so good. How about a corner case though? Suppose that there are 0 people in the room besides me who's do the counting. In line 1, we again initialize n to 0. This time, though line 3 doesn't execute at all, that is n is equal to n plus 1, since there isn't a problem in the room, and so n remains 0, which indeed matches the number of people in the room. Pretty simple, right? But counting people one at a time is pretty inefficient. Surely we can do better than this. Why not count 2 people at a time? Instead of counting 1, 2, 3, 4 and so forth, let's do the counting by, why not counting as 2, 4, 6, 8, so on. It even sounds faster, and it surely is. Let's express this optimization in the pseudocode. So the initial stage would be let n is equal to 0. For each pair of the second step, for each pair of people in room, let's set n is equal to n plus 2. Rather than count 1 people at a time, we instead count 2 at a time. We are going to count 2, that is a pair at a time. This algorithm thus it saves twice the time. Let's see, does it work if there are 2 people in the room? In line 1, we initialize n to 0. For that one pair of people, we then increment n by 2. And so by this algorithm's n is 2, which indeed matches the number of people in the room. Suppose next that there are 0 people in the room. In line 1, we initialized n is equal to 0. As before itself, I told you line 3 doesn't execute at all since there are 18 pairs of people in the room. And so n remains 0, which indeed matches the number of people in the room. But what if there are 3 people in the room? Will the algorithm work, or how does this algorithm is fair? Let's see. In line 1, we initialize n to 0. For a pair of those people, we then increment n by 2. But then what? There isn't another full pair of people in the room. So line 2 no longer applies. And so by this algorithm's n is still 2, which is not correct, which is incorrect. Indeed, this algorithm is said to be buggy one because it has a mistake. Let's readdress this sum with the new pseudocode. Let n is equal to 0 for each pair of people in a room. Set n is equal to n plus 2. If one person remains unpaired, then set n is equal to n plus 1. Let's see, to solve this particular problem, we have introduced in line 4 a condition that is otherwise known as a branching condition, that only if it executes if there is only one person, we cannot pair with another person. So now whether there's 1 or 3 or any number of people or odd people in the room, this algorithm will now count them. Can we do even better? We could count in 3s or 4s or even 5s and 10s, but beyond that is going to get a little bit difficult to point it out. At the end of the day, whether executed by computers or humans, algorithms are just a set of instructions with which to solve problems.